discussion tonight. Go ahead and bring in our co-host and guest for the night. We have Momma Atheist co-hosting with us, and we also have Dr. Lawrence Krauss hanging out with us tonight. What's going on?
Well, it's a nice evening here, not raining in Oregon, and happy to be with you virtually.
Absolutely, yeah. I spent quite a few years in the military up at Fort Lewis up in Washington, so I know the rain. I know that very well.
Beautiful sunny day, and no ice storm, and I have power, which is for lately an unusual thing for me.
Yeah. So, Momma Atheist, how are you?
I'm good. How are you?
I'm doing all right. Glad to finally have you on the show co-hosting. If you guys want to, real quick, just go ahead and plug your channels. What's going on? What's coming up? Anything that you'd like to mention?
After you, Dr. Krauss.
Oh, you want me to go first? Okay. Let's see. Well, of course, my new book is out in a variety of forms, in audiobook and ebook, and it comes out on Tuesday in hardcover in the United States. It's been a while. The pandemic, it was supposed to be out earlier, but the pandemic's delayed it. So the official pub date is Tuesday, and that's nice. And my podcast is about to have a new guest. Last month's guest was Andrea Ghez, who won the Nobel Prize in Physics. The month before was Woody Allen, and which was a very interesting interview. And probably sometime early this week, we'll be releasing the new podcast with the amazing writer Ian McEwan, and it's he's a fascinating guy and a friend. So that's coming up there, and I'm going to do a live lecture on the physics of climate change for my foundation, and it's on YouTube, and you can go to the www.originsprojectfoundation.org and register for that. The lecture's free online, and then there's a premium ticket will take you to an hour live Q&A with me. So that's March 5th, 6 p.m. Pacific Standard Time. So that's coming up. I guess those are the major things. And
all right.
Yeah, and if you're in Congress, we're going to send you a copy of my book. We're sending 600 copies of the book to every member of Congress and a bunch of people in government in a week and a half.
Fantastic idea.
All right. If it works out, Momma.
All right.
Your turn.
Momma Atheist, you're up.
Hi, I'm just Amanda. I'm a climate scientist. I have a tiny little channel on YouTube, and I talk about science and atheism and politics. I bitch a lot about politics, so I'll admit to that.
Well, we've had plenty to talk about in the politics realm within the last couple of months.
Yeah, we really have. So.
I think we have everything for both Dr. Krauss and Momma Atheist in the description below. So if you want to go ahead and visit their channel, show them some love, check out Dr. Krauss's books, and check out Momma Atheist's channel. See if it's something that you might enjoy. That would be awesome. And I already said everything for this channel. But yeah, if you guys want to, we can go ahead and just open this up to an open conversation about climate change or the physics of climate change. I don't have a degree or anything in the subject, so I'm going to be pretty much here learning. First off, Lawrence, Dr. Krauss, what is climate change for those of us that don't know?
Okay, well, by the way, the book is for you, right? It's not meant for people who have a degree in physics, but it's meant
okay, cool.
Because I think it's really important. No, I wrote it because I think it's really important to if we're going to have sensible public policy, the public has to have some sense of what the realities are, and so it's a book that I don't discuss policy at all. It's just the science behind climate change, which is understandable by anyone, certainly with a high school physics education, and maybe even not that, and the history is interesting, and the science is 200-year-old science. People have this misimpression that to understand the basic features of our climate, you have to use supercomputers, and the models are very iffy and predictions are iffy. But in fact, the fundamental physics is well known, to almost 150 years old in many cases, and understandable. And fun to learn about. So that's why one of the reasons I wrote it. But what we're talking about here. Of course, climate changes over geological timeframes and cosmic timeframes as the Earth's orbit changes and other things happen. But what we're talking about in this case is climate change induced by humanity, which means change in the global configuration of the planet so that things like the average temperature of the planet and the average temperature in various locations, sea level rise, acidity of the oceans, the global features of the planet are being changed by human industrial activity. And understanding how that's the case and predicting both the general features of what might happen and speculating about specifics in different locations is the work of climate science. And I'm not a climate scientist, and so I think that was one of the reasons I wrote the book too, because I'm a scientist, and I'm a scientist who spent a lot of time trying to explain things to the public. And if I can't understand climate science enough to explain it to the public, then how can we expect to have any rational conversations politically or otherwise? And so I felt I was kind of a test case in that regard.
So I was wondering, when you come up against those that are serious climate deniers, and they specifically about it being, whether or not climate change is anthropogenic, and you have things like the Keeling curve, showing years and years of the carbon levels going up. We can tell the carbon is at over 410 parts per million in the atmosphere now. That doesn't seem to matter. We're dumping 10 gigatons of carbon into our atmosphere every year. Doesn't matter. What are the things that what is the ammunition that you use in order to kind of back up the idea of anthropogenic climate change?
Well, I think, look, there's some people you can't convince of anything. It's like talking to religious fundamentalists. There's some people that you can't change your mind, but those aren't the people you're arguing those aren't the people you really care about. What you care about is a vast group in the middle who don't know about it and are willing to sort of have an open mind in that regard. But one of the things I think you can do to overcome people's innate, certain people's innate denialism is the same thing I've used in say, the physics of Star Trek, or sometimes even in religious debates. Namely, the only way to really learn is to confront your own misconceptions. So there are surprises about climate change that I think confront people's intuitions, which are useful to talk about, and I've talked about them in the book. I mean, one thing that was actually surprising to me when I was researching it, and I should say I was chairman of the board of the Bulletin of the Atomic Scientists for a dozen years, and we set the doomsday clock, and every year we'd have a symposium talking about existential threats. And so I was tutored for 12 years by a lot of colleagues and friends who were climate scientists. But once I started to look into it for myself, the fact that the sea level is rising, and that's okay, but you often hear that it's just due to glacier melting or worrying about West Antarctic ice sheet or Greenland ice sheet disappearing. But what a lot of people don't talk about is the fact that up till now, almost half of that sea level rise is just due to simple physics. We've dumped heat in the ocean
makes it absorb the water.
And as water heats up, it expands. And so there are things that are written in stone that aren't going to change. It takes the ocean a long time to thermalize and equilibrate that water, that heat. But over the last 25 years, as one Japanese scientist determined it, we've dumped in the equivalent of 3.6 billion Hiroshima-level atomic bombs worth of heat. 4 atomic bombs every second, 24 hours a day for the last 25 years. And that heat, that means by 2100, no matter what we do now to slow carbon production in the atmosphere by fossil fuels, the heat we've already dumped in is going to result in almost a third to a half a meter of sea level rise, just from physics of the fact that you heat it up, it expands. There's nothing you can.
That's if we completely cut carbon emissions, or we completely cut the use of fossil fuels this instant. Too.
Yeah, if we cut it now, it's guaranteed. It's written in stone already. It's often I talk in the book about it's like the Dickens story about the Christmas present, Christmas future, the future as it might be and the future as it will be. Well, there's some things that we can't do much about, and the fact that sea level rise will be at least a half a meter is something that's written in stone because of what we've already done, even if no matter what we do in the future. And that's significant. As I say, a half a meter may not seem like a lot for some people, depending upon where they're living. It's all a matter of perspective. If you have a bowling ball above your foot, half a meter seems pretty big. And the point is that a significant fraction of the world live less than a meter above sea level. And my book begins and ends in the Mekong Delta, where I was in January, a little over a year ago, leading a trip. And it really hit home because there's this incredible delta, the richest rice-producing region in the world. And almost all of South Vietnam is less than 1 meter above sea level. And this Mekong River holds back the sea right now, but with a half a meter sea level rise, that's not likely to continue. And all of that flooded region, which is so good for producing rice, will be turned into brackish water and mangrove swamps, and 60 million people depend upon that for food. Plus, it's the richest fish-producing river in the world. So, in any case, things like that people don't expect and are really hard to argue with. It's hard to argue with the fact that water expands when you heat it up, and then other things like that were also surprising. That in some sense, global warming, the real factor isn't what's happening on the surface of the Earth; it's what's happening at the top of the atmosphere.
Yeah,
and explaining that is very non-intuitive, and I think is interesting because once again, you can explain it in terms of fundamental physics, and it's hard to disagree with. It's also not an argument that people are used to countering. When I used to talk to young Earth creationists, they're always used to I used to love to invent new reasons why the world wasn't 6,000 years old, because they heard, they've done the radioactivity argument, they have these things built up, and I'd like to come with every week with a new thing that they hadn't yet been used to arguing against. And similarly, when you hear a lot of the arguments against climate change, you don't hear a lot of people talking about the upper atmosphere. So if you can hit people with new things that surprise them, that's useful. That was a long answer to your short question.
When you speak, sorry, Justin, just one more quick follow-up question on this.
Yeah.
When you speak about the upper layer of the atmosphere, you're talking about how increasing carbon emissions increases also the opacity of the atmosphere, which means you have to travel further up and you have less amount of space in order to release radiation from the atmosphere, from the Earth into space.
Exactly. It's not so much less amount of space, but you're right. It's higher elevation. So the opacity of the atmosphere is increased. So the fundamental equation is really simple. Energy in equals energy out.
Yep.
And if it isn't the case, then something either heats up or cools down. I mean, it's not rocket science. And so the Earth receives a fixed amount of radiation from the sun, and if it can radiate it all back into space, then it remains at the same temperature. But if more radiation comes in than goes out, then the Earth heats up. And the point is, the radiation that the Earth radiates into space, all hot bodies radiate as the fourth power of their temperature. That's a fundamental fact of physics. Now, as the atmosphere becomes more opaque, the Earth, in order for the radiation to get into space, it has to emerge from a higher level of the atmosphere. But higher up, the atmosphere is colder. And since the rate of radiation goes as the fourth power of temperature, the Earth is radiating less from a higher elevation, and that means there's a small difference in what the Earth is emitting versus what it's absorbing. We call that radiative forcing. And basically all of the physics of climate change comes into the fact that there's a certain amount of what's called radiative forcing, which can be measured as well as calculated, and it's somewhere between 2 and 3 watts per square meter extra power that's coming in that isn't going out. And when you average that over the entire surface, that's a lot of heat. Okay.
And as we continue to dump, like I said, it's something like 10 gigatons of carbon into the atmosphere, and that's just carbon. Methane, there's something like 1,875 parts per million. It's 2.5 times the amount of pre-industrial levels. So carbon alone, you keep adding to the atmosphere, then it's just going to get worse and worse.
Yeah, and well, that's the other thing that's important to add to this, because people often say, another misconception, people say, well, why don't we just wait till the economy is better to deal with this? And as I like to say, when it comes to carbon in the atmosphere, it's like Las Vegas. What happens in the atmosphere stays in the atmosphere, and so the carbon atoms themselves don't stay, but there's exchange with the ocean. So the carbon abundance, the half-life of the carbon abundance in the atmosphere is almost 1,000 years. Yeah. So that means if we'd started, let's think about this. Before pre-industrial times, the carbon in the atmosphere is about 600 gigatons. Okay, now if we'd started acting to reduce carbon to become carbon neutral, say in 2010, versus now. That's 10 years. Each year, as Amanda pointed out, we're adding 10 gigatons. So that's 100 gigatons that we've added in the last decade. That's going to, and maybe half of it stays in the atmosphere, some of it the rest in the ocean. So 50 gigatons that stayed in the atmosphere, you know, that's almost 10% increase in the total abundance of what carbon there was in the atmosphere. So the longer we wait, the more severe will need to be our cutbacks if we want to keep the carbon level below a certain amount. And so that's the reason there's some urgency, because every year you wait, you're putting 10 gigatons in, of which 5 gigatons is staying, and that's there, and that's going to be there for centuries.
Yeah.
And unless we figure out a way to remove it, of course.
Yeah. Justin?
Yeah, so I had a question. I'm not going to be using any of the fancy jargon that you guys are, but
Okay.
I've always been interested in hearing what kind of response you get, because I know you also, you speak on religion too. So when the people are basically saying we don't really need to worry about this, it's not really an issue, God's going to fix it. What's normally your knee-jerk reaction or first response to something?
Well, I have to say, it's somewhat, although I've spoken about climate change in different contexts over the years, this is, with the new book, this is the first time I've sort of focusing on this, and I'm discovering a whole new level of denial and hate that I hadn't experienced before. Dude.
Yeah,
I'm surprised. It's almost more vociferous than it was with religion. I just produced my last podcast. With my podcast, I had a once a month episode called Science Matters, where I talk about, some science in the news. And I devoted the last months before this one to 5 misconceptions about climate change. And it's had an incredible number of views, which I think great. But then I look at the response, and the response is really angry. And all these people quote, it's interesting. I've seen it, when you debate apologists, they tend to quote the same things. When you debate alien abductee people, they quote the same stuff. And what you see here is that someone has given people the certain kind of misinformation, and they just regurgitate it. They say this is garbage, and you're a scientist, you must be paid by the, and then they'll talk. It really amazed me, because I don't have a horse in this race. I mean, except being human, and they'll say things like, well, but the Earth was warmer in the Holocene, which in fact is not true. It turns out. But they'll say that, and then they'll say, well, but the carbon levels were much higher many million years ago, and you say, yeah, they were, but let's look at what ocean levels were, what was happening, and so I'm kind of surprised and disappointed, mostly because the public, certainly the impression you get is that the public at large is much more receptive to the need to do something about climate change, and it's really surprising to see how strongly the denier, how angry the deniers are. It is a lot like certain elements of religious groups. Now, having said that, I want to point out, I'm also equally concerned. While I'm concerned, one of the reasons we're sending it to Congress is, so people like, the senator from Oklahoma, who brings a snowball into the Senate and says, see, there's no climate change. Well, that's ridiculous. But I'm also worried about, the left, and it's nice to have an administration that accepts the reality of human-induced climate change, but I'm also concerned when there's a kind of religious acceptance of that too. I'm as opposed to sort of blind belief, whether it's pro or anti, when it comes to anything. And so I think it's really important that we also, in the Biden administration, make sure that we tone down those people who are making these ridiculous claims. One of them is, for example, one of the more left-wing members of the Congress, Alexandria Ocasio-Cortez, who said said, if we don't do anything in 12 years, our kids will be dead. Now, that kind of nonsense is equally important to counter, because first of all, it reduces the credibility of people who are actually trying to change things. And we have to make sure. And when people say, well, the storms that just happened in Texas are climate change. Well, you can't really say that. You can say, and Amanda knows this, that you can say the frequency and the likelihood of extreme weather events will increase with more energy in the atmosphere. but you can't pinpoint a specific storm or a specific thing and say, there, that's climate change. And so I think it's really important that we ground public policy on the left as well as the right in reality. And that's really what I wrote that book, because that, that'll ground people in reality. What if you have a sense of what the real predictions are that are firm, and the ones that are more speculative, I mean, which are a lot more worrisome. There are tipping points that are talked about, and lots of things that could be serious, but they are more speculative, and it's nice to know how to rank them. And then you say to someone, like Clint Eastwood used to say, "Are you feeling lucky?" and then you say, "Look, if here's the Greenland ice sheet may have a tipping point at 2 degrees Celsius instead of 5 degrees Celsius. If that's the case, then inevitably there'll be 7 meters of sea level rise as that disappears. Are you willing, even though that's a speculative claim, are you willing to just forget about it, or you think it's worth maybe staving it off just in case?" And so that's the kind of thing that's worth discussing.
What you mentioned with the storms in Texas, us not being able to say, point definitively and say this is our exact, connection between the storms in Texas and climate change. The same seems to go with climate deniers. They will tell us, it's not, there's no human connection, because they're looking for this kind of absolute definitive proof, as if, I have no idea what exactly they're looking for. Do you think what this complete and total proof that connects human beings to climate change without discussing the carbon levels and everything?
I think the point is, there's an old statement saying if it walks like a duck and quacks like a duck, it's a duck. And so you just look and say, well, you take the naive basic physics, you make a simple but robust prediction, and it agrees exactly with the observations. And you say to yourself, maybe there's a huge conspiracy, but they often throw at me correlation is, I've said this in many cases too, correlation is not causation. Correlating one thing with another, it doesn't mean one causes another, unless you have an explanation of why one causes the other, and then the correlation may mean something. And in this case, there is correlation and there is causation, because in fact our basic theory predicts exactly what we see. And so I think that's what you say is, maybe there's an incredible cancellation of things we don't know about that produce exactly what our simplest theories predict. But the easiest assumption is that theories are right when they predict the right thing. Just like I've said in terms of again, religion, and since this that's the title of your podcast. When I talked about a universe from nothing, I said we can't prove the universe came from nothing. But if we ask what would be the characteristics of a universe that came from nothing that was 14 billion years old, it'd be precisely the characteristics of the universe we live in. Well, that's highly suggestive at the very least. Anyway.
Yeah. And they also, in the early mid-2000s, they had compiled all of the climate data that they had over the past, as far as they had it, and were able to, connect the dots between, I think it was something like only a third of that data actually talked about the connection between climate change and human beings, but 97% of that data that had that connection pointed to it being anthropogenic. So
and I point in my book that, in fact, I feel bad. Here's one. Yeah, okay. I should really show it, or if you're I really, you have to decide whether you like the UK cover or the American cover better, but I helped design. Well, anyway, it doesn't matter. But in the book, I talk about the fact, which is really fascinating, that the realization that the numbers were such that it would be very hard to imagine that humans weren't impacting on the climate. That estimate was done by Arvid Högberg, who was a Swedish geologist in 1896. And he did a really simple calculation. He said, let's take all the carbon in the atmosphere, when he estimated roughly, and it was around 300 parts per million at that time. But so they already had a rough estimate, and he said, what would happen if you made it liquid or solid? If you compressed it all down, how thick a layer would it be on the Earth's surface? And it'd be 1 millimeter. And he said, what, life already is from on land, and is already existing on layers much thicker than 1 millimeter around the Earth. And so it's quite likely that life has an impact on the carbon abundance in the atmosphere. And of course, we humans with our fossil fuels are not dealing with just current life, but hundreds of millions of years of worth of life as we've extracted fossil fuels. And so, he already has demonstrated that it would be really surprising if life itself didn't impact on the atmosphere. And it does. You can see it in the Keeling curve, in the way life breathes, as I talk about in twice a year, and in the abundance of that. But it's also not very surprising that humans have impact on it with their fossil fuel production, because we are basically extracting the results of living beings over literally millions of years on the Earth's surface, and so layers much thicker than 1 millimeter. Anyway,
that was one of the questions in the private chats. So sorry, Justin.
Oh no, you're good.
Wes had asked what the deal with permafrost is, and the biggest issue we have, or one of the biggest issues we have with permafrost, is that there is just tons and tons of organic material trapped in that permafrost. So as that permafrost thaws, which it is doing at exponential rates that we had no idea was going to happen like it does, the organic material, it thaws and then it lets off, it decays. And this is hundreds of thousands, millions of years worth of organic material. I think it's something like a quarter of all dead organic material on the Earth is trapped within the permafrost in the Northern Hemisphere. And that is an issue as the permafrost continues to thaw and that organic material decays. We are adding to the greenhouse gases, which is making climate change worse.
Yeah, and it's methane mostly. And your point is that, once again, the permafrost melting is a kind of tipping point where it doesn't happen linearly. There are many reasons for that. And so, it could be, if you turn that switch, you're absolutely right, then it's a much more severe situation we're living in than we live in now. And so, as there's a linear kind of relationship, well, it's logarithmic, between increase the carbon dioxide and the temperature, and so that goes gently. But once you get past a certain point, you turn that switch, then boom, you're releasing all these new sources, and and permafrost is a huge concern. Yes. By the way, I'm mapping this. I don't know whether it matters, but I see someone saying, I'm curious if Krauss has an opinion on the potential for harnessing free energy from the molecular motion of graphene molecules.
Yeah. I'm pulling questions from the chat for us, which we're actually. If you want to dive right into it?
I don't know. But I saw that one and I thought, well, no, I don't have an opinion. I think it's highly. Graphene is an interesting molecule, but I don't know what the purpose of it is. That as an energy generation mechanism, and generally the second law of thermodynamics says it's pretty hard. There's an energy cost to doing that, and so graphene is fascinating, and it's being used in new semiconductor materials and new quantum materials to try and create better transistors and all sorts of things. So it's not as if it's not useful, but I don't see it as it may be useful in solar panels as well eventually, because of the conductivity properties of graphene. Who knows? It's a very interesting material, but I don't think directly extracting energy from it is the way out, if that's the question that was being asked. Anyway, Sorry, I happened to see that one.
Oh no, you're fine. We're actually going to jump into some of these questions, but before we get to the questions in the chat, and I do want to let everybody know that we may not be able to get to everybody's questions because Dr. Krauss does have to go.
I've got, unfortunately, a limited time today. I'm sorry,
about 15 minutes.
Yeah,
we'll get as many questions in as we can. I just wanted to bring a few people in that did have a question or two for Dr. Krauss. We have Sunny Show with us tonight. We also have Cease to Know, and we have David with us also to ask some questions and discuss some things with Dr. Krauss. How's it going, guys?
Hi, everybody.
Good. How are you guys?
Thanks for having me. Thanks for. Can you hear me?
Thanks for inviting us.
Yeah.
Yeah, we can hear you, Steve.
So if you guys want to fire off any questions or anything that you have to ask, and we'll get to it.
Sure.
Go ahead.
I'll go ahead and ask one question.
Okay.
Hello, Dr. Krauss. Nice to meet you. My degree is in philosophy, and I've always wondered whether or not you had any kind of pushback on the notion of nothingness from sort of the philosophy culture and
Sure. Yeah. I mean, huge pushback, because both philosophy and religion, theology communities were concerned by what I meant by nothing, and I was very clear in my book to define it as a scientist would, because I think it's a physical quantity, not a conceptual quantity. It's the absence of something, and something you can measure, and so there's been a lot of pushback, and there was a philosopher of science who particularly didn't like it, and he quoted something, and then I just read people who I know don't understand what they're saying, but they're quoting it. They're saying Professor Krauss isn't talking about absolute nothing. He's talking about a quantum foam or the quantum vacuum, and they don't know what they're talking about. I really meant nothing in the sense of no space, no time. Our universe, which exists now, literally did not exist. Now, whether there was something else is not a question that I was asking, and so the sort of the deeper philosophical religious question of whether absolutely nothing existed and then our universe existed is not the question I'm asking. I'm asking, our universe didn't exist, it then did exist, so could it spontaneously come when it's from nothing in the sense it didn't exist? Whether there was an infinite past and a multiverse and everything else, those are interesting questions, but those are elephants all the way down as far as I'm concerned, or turtles. Right. So the other fact they didn't like is the fact that we changed the definition of nothing. They don't like the fact that physics tells us there's not really a difference between nothing and something at a variety of levels because of quantum mechanics. Because in regular empty space, which some people like to think of as nothing, in fact the Bible tends to talk about an infinite void and they mean empty space, that's not nothing at all in physics, because it's full of virtual particles popping in and out of existence. So that kind of nothing is not nothing. I mean, there's not a lot of difference between nothing and something, because you're guaranteed in such a world that quantum fluctuations will eventually produce something.
The idea that nothingness is completely unstable. So if there was absolute nothingness beforehand and these quantum particles popping in, that could have resulted in the.
If you wait long enough, yeah. But then the other thing is, if you have quantum gravity, where space and time become quantum objects, and we don't have a theory of quantum gravity, but any theory of quantum gravity is going to be a quantum theory of space and time. Then, in such a theory, it stands to reason that space-times themselves will pop into existence, and so you'll actually create what we think closed universes that will pop into existence, and some of them, under right conditions, could exist for 14 billion years. So anyway, but I think what they didn't like was the change in the definition of nothing, and the fact that I wasn't necessarily addressing the question they wanted me to address. And I don't really care about the question they wanted me to address, which is, I wanted to ask, is it possible for our universe to appear from nothing? Not the deeper question of why anything exists, which is a question that I know is a deep supposed interest to philosophers, but I don't think anyone has anything useful to say about it.
No, I'm on your side as far as that. I think the interesting question becomes how to bridge science and philosophy in a way that is constructive and useful. And I think sometimes there is sort of miscommunication and a talking past each other, where a lot of scientists are bad philosophers and a lot of philosophers are terrible scientists.
Well, let me point out that I like to say most physicists can't spell philosophy. Okay, so it's not that they're bad philosophers, because we're all doing natural philosophy. That's what science is. But when it comes to academic philosophy and reading the philosophy of science, physicists just don't do it. Now, that doesn't mean it's not interesting, but it has no impact on the operation of physics, because physicists don't read it. And so, and the reason is, philosophy really is useful in areas of science where the questions aren't well framed. That's why it's so interesting in consciousness. And so where we really don't even understand consciousness, and philosophy, by framing interesting questions, can help direct science. But physical science is so far advanced now that the philosophical questions that we drove the early development of modern science are really not what's driving physics now. I mean, the general questions, how did the universe begin? That is, but philosophers aren't really driving science, and most physicists don't even read philosophy. And as I say, that's okay. And it doesn't. It's not a pejorative to say that, although some people I got in trouble because of the joke I made in the book, at the beginning, saying that but I was really lumping philosophers with theologians when I said they don't like my definition of nothing, but because they're experts at nothing.
Right. No, I don't think I'll say a lot of philosophy of science, I think, is just non-understanding science. There's a lot of garbage out there. So, part of what I'm trying to do is educate people on what is actually good philosophy.
Yeah, and you can educate me, and I certainly have friends who are philosophers who educate me all the time, on a variety of subjects. And so people think I'm hostile to philosophy. I'm not really, but anyway, it's interesting. But I want to try and get through all three people before I have to leave in 6 minutes, or 7 minutes. So, should I do Sunny next, and then David? Okay, because that's the order I'm seeing you on the screen. So,
well, mine is a very simple question. I actually had a lot of different questions, but I wanted to ask one for my son who wants to be or has talked about being a theoretical physicist.
Okay.
What would you think the best advice that you would have, both for me as a parent of a child who wants to be a theoretical physicist, and also for him? What would be the best advice that you would have for us?
Well, I think the advice is to just remember to remain excited and fascinated by the universe, because it is fascinating, and he's lucky, or he or she, they're lucky right now to be able to access so much information online. But to be very careful when they're looking at things, to try and check their sources, but ultimately to keep asking questions and not be afraid to not know. And not even be worried when mother doesn't know, or when their teacher doesn't know, because those are the most exciting questions to ask. And if the teacher is bothered by not knowing, then don't worry about it. Don't let what I wouldn't tell them in these words, but I often tell older kids, is don't let the bastards get you down. And I think the point is that to keep them. There'll be times in studying science, and to remember, the other thing is to work hard and to. That math is very important, and sometimes it may seem hard, but working hard at it makes it easier, and not to be discouraged if they're not the best in their class in something. I have many colleagues, friends of mine, who've won the Nobel Prize who weren't the best in their class in mathematics in any way, and so science, when it's operating well, takes people of all different talents and skills, but a quantitative, being able to be comfortable with mathematics is really important, and they should do that. And then if they want to read popular books, which certainly for me, it had a huge impact on me when I was young, reading popular books by scientists, by Isaac Asimov and George Gamow and Richard Feynman and Albert Einstein. And I would suggest that they read books by scientists, not to put journalists down, because there are some good journalists, but it's nice to see what's going on. So but just keep having fun. It is exciting, and don't be afraid to not know. Anyway, those are some ideas. I hope some of that helps. Okay. Sure.
It absolutely does. Thank you.
Thank you. Good luck. And then David?
Yes, I have a quick question about the dark sector of the universe.
Yes.
Dark energy is fairly recent, 20 years or so, but we've been searching for dark matter for longer than that. I'm wondering, what's your prediction for 2200? Are we going to be still going to be looking for both?
Well, if you've ever heard before, I don't like to make predictions of anything less than 2 trillion years in the future, because then A, it's easier, and B, no one's going to be around to check my answers. But
what if you had to bet?
Well, look, I've been thinking about dark matter for 40 years, and I proposed the first set of experiments that are being used to look for dark matter. And I thought in the 1980s, I thought, okay, well, here's the neat idea, and they'll take 5 years to build it, and then it'll be discovered. And then I realized how much harder it is to be an experimentalist, and the experiments we were talking about refining took 20 or 30 years. I think there's every reason to believe that we will. I'm more optimistic that we'll be able to discover the candidate for dark matter in this century. I think there's every reason to believe it's possible. It's not unlikely. Whereas dark energy, I would be amazed if we understood dark energy in this century. Because dark matter, all theories that expand on the standard model of particle physics, all of them predict different kinds of dark matter. And there are very easy ways to produce it in the early universe and have it in great abundance. So it'd be surprising if there weren't dark matter in some sense. So there are lots of good candidates. There's lots of really good, firm reasons to expect that some of our ideas are correct there. Whereas with dark energy, we don't have the slightest idea why empty space has energy. It confounds all of our pictures of physics, all the way, including string theory, by the way. And I
what
suspect
about the discrepancy between how much dark matter that we think that we know of and how much dark energy there really should be, as opposed
dark
to what?
energy? Dark matter is about the right amount, but the dark energy, yeah, it's 120
Yeah,
orders
that's what I'm saying.
Well, it's not how we think it should be. We originally thought it was zero, and then we were really surprised that there was any energy in empty space, because zero was a natural value. And then when there was, the answer is, well, what would be a natural amount if it wasn't zero, and it's 120 orders of magnitude larger? And that's a big mystery. But I think to answer that mystery, we're probably going to have to have a theory of quantum gravity. And so I don't think that's an easy... Look, it's near and dear to my heart. I was one of the first people to propose that dark energy existed in 1998. 1995, I should say. They discovered it in 1998.
Are you the one that named it?
No, actually, my colleague, me and Michael Turner first proposed it, and Michael called it dark energy because, it's in analogy to dark matter. But yeah, in 1995, we wrote a paper which no one believed, which argued that the data suggested there was dark energy, and it was exactly right. It turned out the observers measured it, and to their surprise, they found out they didn't measure because we told them to, and they discovered it, and then they won the Nobel Prize. So that's the way it goes.
You have that problem with trying to put relativity and quantum physics together when you have that discrepancy. So
well, I mean, there just is a huge problem with putting general relativity and quantum mechanics together. String theory is a very well-founded idea to try and do that. It hasn't really been successful, and it's a hard problem, and it may take a long time to solve. So, but that's okay. It's fun to have existing mysteries. Not only does it give us job security, but the seeking is almost sometimes better than the finding, which is probably a good thing for me to say as I leave.
Yes, I got one more. I have one more question for you, Dr. Krauss, and it's a little tongue in cheek, and then we'll get you out of here. First off, I'd like to thank you for coming on. We really appreciate it and answering all of our questions and whatnot. But our Christian friend James.